moving on to C. Notice in C that we want to find, again, a common denominator. But notice that second denominator actually can be factored. So in order to find a common denominator, we actually have to factor that denominator first. Well, notice that that denominator is a difference of 2 squares. So we want to factor that first. And a difference of 2 squares means it'll factor as a y plus 3 and a y minus 3. Notice that both fractions have a y plus 3. So that is definitely going to be a part of our common denominator, the y plus 3. Notice the only difference between the two denominators is the y minus 3. So if I just go ahead and tack on the y minus 3 to the other fraction's denominator, we would have a common denominator. So that's what we're going to do. We're going to multiply the denominator of the other fraction by a y minus 3 so that they are the same. But then if I do it to the bottom, I've got to do it to the top, which means I need to distribute out or multiply out the y and the y minus 3, which will get me a y squared minus 3y. Now my other fraction already has the y plus 3 and the y minus 3 on top, so it's completely perfect and can stay the same as 2y minus 6. But I do need to be careful because of that minus sign out in front. I do need to distribute the minus sign to the entire top because I'm subtracting, which will give me a negative 2y plus 6. And then let's cancel out that negative sign because it's already been used. Now that we have a common denominator of y plus 3 and y minus 3, it will stay the same. I can just add and subtract across the top and combine like terms. Notice I've got a negative 3y and a 2y that will add up to become negative 5y. The other pieces on top are the y squared that comes first and the positive 6 that comes at the end. Notice it was a positive to 6 because we distributed the minus sign. Now again, you might think that you're done, but the question is, can the top be factored and reduced? And the answer is yes, the top can be factored. Notice, if we factor out the top, it factors out as a y minus 2 and a y minus 3, which, if we look at the bottom, means we have a common identical factor of y minus 3 on the top and the bottom, which can be canceled out, which would leave us with our final answer of y minus 2 on the top and y plus 3 on the bottom. Notice on this next one, we have two completely different denominators, an x plus 2 and an x minus 3. So the first fraction has a denominator of x plus 2, and the second one has a denominator of x minus 3. So to get a common denominator, the easiest way to do this would be to include both denominators. So we've already got an x plus 2 on one side. We need to pick up the completely different denominator of x minus 3. So we're just going to multiply the bottom by an x minus 3. But if we do that, we also have to do it to the top as well. On the second fraction, we already have the x minus 3. We're missing the other fraction's denominator, the x plus 2. So we'll multiply the bottom and the top by the x plus 2. Now this looks messy, but at least now the denominators are the same. They both have an x plus 2, and they both have an x minus 3 on them. So if I want to work out the numerator so that I can add these two together normally, that's exactly the path that I want to take here. So on the numerator, the first one, I need to be multiplying out the 2x to everything, and that would give me a 2x squared minus 6x. Notice I can write them all in the same fraction now because they have a common denominator. On the second piece, let's see. I want to look at multiplying the x plus 1 and the x plus 2. There is no other way to do this than good old FOIL. So let's FOIL it out, and we will get x squared plus 2x plus 1x plus 2. Let's go ahead and extend our fraction. So again, everything's on top because we are combining like terms. So we can go ahead and continue along. Let's see. The denominator keeps on staying the same once you have a common denominator. So let's see what can be combined. So first of all, we have a 2x squared and an x squared, which is going to give us 3x squared. And what else do we have? We also have a negative 6x, a 2x, and a 1x, which when added all together will give us a negative 3x, and we have a, let's see, a plus 2 that's kind of off by itself. So now your question would be, does that top factor to possibly cancel out with the bottom? You try AC method, which is 3 times 2, which is 6. Are there any factors of 6 that add up to the middle number, negative 3? And no, there are not. So that means it does not factor, and we are done. That was a complicated one, but it's all done. The next one, let's try again. Again, we've got 3 different fractions with 3 different denominators. The question is, if we're going to get a common denominator, do any of the denominators factor? And yes, the denominator on the last one does factor. So the first 2, let's start out by just rewriting them right away. We'll see what the common denominator is in just a second. But that last one factors out as, well, there's a GCF, or common factor of x. So that will factor out as x minus 3 after you factor out the x. Now notice our greatest common factor of x helped us out quite a bit, that our x and our x minus 3 are actually the denominators of the other 2 fractions. So what we want to do here is find our common denominator, which we can get away with just using the x and the x minus 3. Well, we already have that in the last one, so we don't even need to change the last fraction. The first fraction, however, has the x minus 3. It's just missing the solo x. So we can get away with just multiplying the top and the bottom by just an x. And then it has the x and the x minus 3 on the bottom like the last one. So it would be all set to go. The middle fraction, however, has the x. It's missing the x minus 3. So that one would just need to get multiplied by an x minus 3 on the top and the bottom. That would get us our common denominator of having both an x and an x minus 3 on all 3 fractions. So on top of the first one, let's see what that does. Multiplying the top by an x, well, 5x times x gets you 5x squared. Multiplying the top of the middle one by an x minus 3 means you distribute the 2 to the x minus 3, which would get you 2x minus 6. So now we can just add and subtract across the top. Well, if we add or subtract across the top, well, the 5x squared doesn't have anything to combine with it, so it's going to stay the same. Same thing with the positive 2x. But notice we do have, let's see, a negative 6 and a positive 6. What happens when you add a positive 6 and a negative 6? They cancel out. So those will just cancel out completely when you add them as like terms. Now, that means we're just left with the 5x squared and the 2x on the top. The question is, again, can you factor to reduce this? And absolutely you can. If you look at the numerator of our almost final answer, is you can factor out an x from both pieces on the top. So let's do that. That will leave you with 5x plus 2. And on the bottom, we already have the x and the x minus 3. So notice, what can we do now? We can cancel out that common factor of x on the top and the bottom, which will leave me with my final answer of 5x plus 2 over x minus 3. They have nothing in common, so that is your final answer.